Hey, AP Stat students. Today, this lesson is going to be about one way we can measure location within a distribution. Okay, so what do I mean by that? Sometimes in life, we want to measure an individual's location. An example of this would be within a distribution. An example of this would be if you're in band, right? I was in band in middle school. I played the trumpet. I wasn't very good. I went to sectionals, where you go and you meet with your band instructor. Well, what they did is if you're in music, they rate you. And depending on how well you are, you're either the first chair all the way down to the last chair. So first chair is the best, second chair, third chair, so on and so forth. I wasn't last chair, but I was second to last chair. In my defense, I never practiced. I wasn't very good. I didn't really like it that much, but they did test me. They had an assessment process, and they then made a decision based on my location within the distribution of where I should go. My son, he's trying out for hockey soon, okay? He's going to go to tryouts. There's a measurement process. They will rate him within the distribution of hockey players, and then they will make a decision. They'll place him on a team, right? A team, B team, so on and so forth, okay? Many of you in life have gone through processes like this already, and you'll continue as you get into college, as you go find jobs, so on and so forth. What I want to talk about today is one way we can measure a person's location within a distribution, or an individual's location within a distribution. One way to measure it is to find its Z-score, okay? It is imperative you take notes for this lesson, okay? So get your notebook out and your pencil out if you haven't yet. Okay, so what is a Z-score? A Z-score is the exact standard deviation an observation is below or above the mean, okay? The further the Z-score is from 0, the more unusual it is, which means the chances of it happening are pretty rare. A Z-score of 2 or -2 is the benchmark for being an unusual observation in the normal distribution. Note that I have the normal distribution there. That is imperative that you know that, okay? Lots of your problems will say if the distribution is normally distributed or blah, blah, blah. We'll practice that together. Okay, now there's a formula for finding this Z-score, and that formula is right here. You take the observation, okay? So if you're looking at test scores, the observation would be that individual's test score, right? Minus the mean of all the test scores, divided by the standard deviation of the test scores. That's how you calculate a Z-score, okay? Remember to be pausing along the way as you are working with me. So we have our first problem here. Example 3, in 2009, the mean number of wins was 81 with a standard deviation of 11.4. This is for Major League Baseball, I believe, okay? Find and interpret the Z-score for the following teams. AP World is really big on the interpreting because they want to know that you're not just a number cruncher, that you actually understand the concept behind it. So that's my job, to help you understand that, because I know a lot of you are great number crunchers already. Okay, so the New York Yankees had 103 wins. Okay. So we want to find their Z-score. Let's do that now. Okay, so the 103 right here, that is our observation. That is what is happening to the New York Yankees. Okay, so the mean we know is right here, 81, and the standard deviation is 11.4. Now, I forgot to tell you one thing. There's an acronym that I like to use to remember the Z-score formula, and that is ZOMS. And you'll hear me talk about ZOMS a lot. Your Z-score is equal to your observation, O, minus your mean, M, divided by your standard deviation. So we're going to find the Z-score right now for the New York Yankees. Z is equal to our observation, 103, minus our mean, 81, divided by our standard deviation, 11.4. Now, what I want you to do is I want you to pause it and I want you to calculate this, because believe it or not, I get a lot of errors on this problem, okay? So pause it right now, calculate it, and let's come back. Okay, did you get 1.93? If you didn't, my guess is you typed it in your calculator wrong. You need to remember order of operations. So if you type it in all together, you do need parentheses around the numerator here, okay? And that will give you 1.93. Try it again if you didn't get that, okay? Now what I want you to do is I want you to try the New York Mets on your own. So pause it right now, find the Z-score, and then come back. Okay, so you should have just paused it to find the Z-score for the New York Mets with their 70 wins. So Z is equal to 70 minus 81 divided by 11.4, which gives you negative 0.96. Now, one question that will come up is, how far do I need to round? With a Z-score, you only need to round to the nearest hundredth. Friendly reminder about rounding, okay? Rounding, what you want to do is you want to look at the next number. If that number is 5 or above, then you round this number here in the hundredths up, okay? Some people forget how to round. Not a problem. Just wanted to give you that reminder. Okay, now, more importantly than number crunching, than finding that Z-score, it's that interpreting. Now, how do I interpret? Let's go back up to the definition. The definition is that is the exact standard deviation is, a Z-score is the exact standard deviation an observation is below or above the mean, okay? So let's talk about the Yankees. The Yankees have a Z-score of 1.93. That means the New York Yankees with 103 wins were 1.93 standard deviations, right, above the mean, where the New York Mets with 70 wins were 0.96 standard deviations below. How did I know they were below the mean? Because it's a negative value. So we're above the mean if we have a positive value and below the mean if it's a negative value. Let's practice writing it out right now, just so you have a good example for your notes. Okay. A Z-score of 1.93, an observation of 103 has a Z-score of 1.93. The New York Yankees wins of 103 is 1.93 standard deviations above the mean. Okay. So that is how you're going to phrase things. So you're going to practice that in your homework. I'm going to check it and we'll go from there. So I will be looking at your homework just to make sure you're on the right page, and make sure that you check your comments from me so you know that you're doing it right or wrong. Okay, the next reason that we like Z-scores are Z-scores allow us to compare things from different populations. It's a way to compare almost apples to oranges equally, right? Okay, think of it this way. You take the ACT, your brother takes the SAT, and you're like, oh, I did better than you. And your brother's saying, no, I did better than you. And your mom says, well, how do you know? They're different units, right? What a Z-score does is it allows us to compare things to the mean and say, relative within the population, who did better. So here's another baseball example for us. 3 landmarks of baseball achievement are Ty Cobb's batting average of .42 in 1911, Ted Williams of .406 in 1941, and George Brett's of .390 in 1980. Now, why did I have an arrow here, an underlined arrow here? These are all of our observations. Okay, we have 3 different observations within 3 different time frames. Okay, these batting averages cannot be compared directly because the distribution of Major League batting averages has changed over the years. Kind of like how I said, you can't compare ACT to SAT. They're 2 different things. Okay, the distributions follow a normal curve, except for outliers such as Cobb, Williams, and Brett. Well, the men's batting average has been roughly constant by rule changes and the balance between hitting and pitching. The standard deviation has dropped over the time. Here are the facts. Okay, let's keep reading. I don't want to give my spoiler away. Yikes. Give me a second. Okay, compute the standardized batting averages for Cobb, Williams, and Brett to compare how far each stood above his peers. Now, here's the deal, guys. If you see something called find the standardized score or anything about being standardized, that means find the Z-score. Those are synonymous. The standardized score and Z-score are synonymous, meaning do the same thing, okay, for Cobb, Williams, and Brett. So what I want you to do right now is I want you to pause and I want you to find the Z-score for Ty Cobb, for Ted Williams, and for George Brett. If you're confused on what to do here, okay, that might mean either to rewind and rewatch how to find a Z-score or come visit me in office hours and I can help you individually over this, okay? All right, so you should have paused. You should have found the Z-score. So for Ty Cobb, right, we have 0.420. He's in 1911, so he's in the decade of the 1910s. I take 0.420 minus the mean, so observation minus the mean, divide by the standard deviation, and I should have gotten 4.15. Next, to find Ted Williams' z-score, observation 0.406 minus 0.267 divided by 0.390. Divided by 0.0326. So observation minus the mean divided by the standard deviation. And I should get 4.26. And finally, George Brett, he's in the 1980. So we're going to go with the decades of 70s there. 0.390 minus 0.261 divided by 0.0317. And he had, 4.07. So now what we're able to do is we're able to look at this and we see, even though Ted Williams' batting average is below Ty Cobb's, when you transfer them and you look at them all compared to their mean within that decade, Ted Williams does better relative to his peers here or I shouldn't say peers, relative to the other players within their decades. Okay. So we want to write that down. We want to interpret that. What does that mean? Okay. So we're going to write this down. Now, a couple things I should tell you though. When you find a z-score, you must show your work. Okay. I know it's super easy just to punch it into your phone or into your calculator, but you must show your work on the AP test. Okay. Also, your interpretation needs to be in context. So let's interpret what just happened here. As to who was the better baseball player relative, what do you need to do? Find the z-scores for each within the distribution and then say who had the most extreme z-score. Okay, two things. Now, Ted Williams was the best hitter. Relative, that's an important piece when you're comparing from different distributions relative to the other baseball players because he had the most extreme z-score. And that's a perfect answer right there. Okay, so let's sum this up. When asked about a more outstanding performance, okay, or how someone compares relative to the population they are part of, what do you need to do? Standardize both scores relative to each observation's population by finding the z-score first. Then ask which z-score is more extreme second. Then we can summarize it in context. All right, hopefully that helped you guys with z-scores. I'm going to take a break now. We will go on to the next video, part 2, in a bit.